So today we want to see calculations on the projectile. This will be the end of the projectile. So the first question, question 1, a particle is projected vertically upward with a velocity of 30 meters per second at an angle 30 degrees to the horizontal. Calculate the A time taken to reach the maximum height. Time taken to reach the maximum height. B, maximum height attained. C, total time of flight. D, the range. E, maximum range. F, the velocity of the particle at t equals to 2 seconds. The horizontal distance at t equals 2 seconds. H, the vertical distance at t equals 2 seconds as well. A, we are given theta to the horizontal to be 30 degrees, u to be equals to 30 meters per second. We have to calculate time taken to reach the maximum height. So we say u all over g, u sine theta all over g. So t is equals to 30 sine 30 degrees all over 10. T now is equals to 3 times 0.5. 30 times 0.5 all over 10. So t will give you 1.5 seconds. B, maximum height attained. Maximum height is given to be u squared sine square theta all over 2g. H is equals to 30 squared sine square 30 degrees all over 2 times 10. H now will now be 900 times 0.5. Then you now square it. First of all, look for sine 30 degrees. You then square the everything all over 20. So H is equals to 900 times 0.25. Everything all over 20. H now is equals to we have 45 times 0.25. So it will be giving us 1.25 meters. 1.25 meters. That's the maximum height attained. So let's see C part of the question. We have to calculate total time of flight, which is equals to 2u sine theta all over g, or same thing as 2t. And don't forget we have gotten our t to be 1.5. So 1.5. T now is equals to 3 seconds. So D, we have to find the range. The range is equals to u square sine 2 theta all over g. So the range is equals to 30 square times sine 2 into 30 degrees, everything all over 10. This is equals to 900 times sine 60 degrees, everything all over 10. R9 is equals to 900 times 0.8660 divided by 10. So this cancel this. So you have R9 is 90 times 0.866. So the viewers, use your calculator and leave it in meters. 90 multiplied by 0.866. Then E, maximum range, R maximum. You still remember, is U squared all over G. So 30 squared all over 10. 900 all over 10. So it will be 90 meters. The velocity at t equals 2 seconds. V at t equals 2 seconds. Recall that v is equals to vs squared plus vy squared square root. That's the formula for final velocity. So vx is equals to u cos theta. So it's equals to u 30 cos 30 degrees. So 30 times 0.866. So V660, Vx now is equals to 8.66 multiplied by 3. Use your calculator. We are going to get Vx to be equals to, this is 8191 23 20 24, that's 25 meter per seconds. That is Vx. Then you look for Vy is equals to u sine theta minus gt. So it will be 30 sine 30 degrees minus 10 times 2. This one is 30 times 0.5 minus 20. This one will be this one will be 15 minus 20. That will be minus 5 meter per seconds. So we are going to use v is equals to square root of vs squared 25.98 squared plus vy squared minus 5 squared. So it will be 25.98 squared plus 25 square root. Viewers, use your calculator. Find the square root of, define the square of this plus 25, then find the square root. Whatever you get, that's the velocity, final velocity at t equals to 2 seconds. So G, we have to calculate the horizontal distance, Vx, Sx is equals to ut cos theta. So u30 at 2, is a dimension 2, cos 30 degrees. So this one will be 60 times 0.8660. So this one will be 6 times 8.66. Use your calculator. Whatever you get in meters. H, we have to find sy, vertical distance, is ut sine theta minus rgt squared. Sy is equals to 30 times 2 sine 30 degrees minus half times 10 times 2 squared. Sy is equals to 60 times 0.5 minus 2 here will give you 5 times 4. So Sy now is equals to 30 minus 20. Sy now is equals to, that is 10 meters. That's the vertical distance covered at t equals 2 seconds. So that is example 1. Let's see example 2. Example 2. A particle or question 2. Question 2. Question 2. Question 2. A particle is projected vertically upward with a speed of 50 meters per second at an angle 45 degrees, okay, at an angle 60 degrees to the vertical, Calculate the time taken to reach the maximum height. Calculate time taken to reach the maximum height. From here, what is given is alpha 60 degrees. I've told you this is the diagram. When a body is projected, this is theta is always to the horizontal, but it's now given to the vertical 60 degrees. You call it alpha. So your theta now will be 90 degrees minus 60 degrees. So our theta angle to the horizontal is 30 degrees. So we have to find time taken to reach the maximum height. Use sin theta all over g. U 30 is given to be 50 times sin 30 degrees. Everything all over 10. Cancelled. And 5 times 0.5. So the final answer will be 5 times 0.5. It will be 2.5 seconds. So be careful. If the angle to the vertical is given, you have to subtract such angle from 90 degrees to calculate angle of projection to the horizontal. That is example 2. A particle is projected vertically upward from the top of a building 80 meters high, from the top of a building 80 meters high, with a speed of 40 meters per second at an angle 60 degrees to the horizontal. Calculate the maximum height attained above the ground. B. Calculate the total time of flight of the particle in air. C. And the total horizontal distance covered. So this is the question. Let's see the solution. Let's say this is a building. the foot of the building. A body is now projected like this vertically, then it will definitely land like that. This is what we have. So you use your formula to calculate this h. Then we have the height of the building is going to be 80 meters already. So the height, the maximum height of the particle above the ground, as capital H, so it will be from here to here. That is what we are going to do. That is what we are going to do. T1, T is equals to T1 plus T2. The time taken for upward is equal to time taken for downward. Yeah. So it will be, let me call it 2T, because T1 is equals to T2. So we call it T, 2T. So total time of flight 2U sin theta all over G. So it will be T is equals to 2 times 40 sin 60 degrees, everything over 10. Cancel, cancel. T is equals to 8 times 0.8660. T now will now be, we have the 0 here, 48, 84, another 48, 52, 25, 66, 66 plus 5, that's 71. 71. So what we have, that is seconds. Then what of, from here to here is downward motion, and we have done it. T3 is equal to square root of 2h all over g. So T3 is equals to square root of 2h all over g. That is square root of 2 times 80 all over 10. Square root of 16, that is 4 seconds rather. 4 seconds. I give you 4 seconds. So total time of flight now, total time is equals to capital T plus this small 33, 71.280 plus 4. So this one gives you 75.28 seconds. 75.28 seconds. So it's equal to 75.28. 75.28. Let me write it clearly here. 75.28 seconds. So we have gotten our total time. Total time. Total time. The maximum height. Let's see the maximum height attained. Our maximum height will be h is equals to u square sin square theta all over 2g. This one will be 40 squared sin square 60 degrees all over 2 times 10. This one gives you 1600 times 0.8660 squared divided by 20. This one will cancel this. We have 80 yes times 0.8660 squared. So whatever you get here, that's your height. The viewers, use your calculator and type the answer in the comment section. So in meter, whatever you get in meter, then the total height above the maximum height above the ground will be our HA plus height of the building plus 80 plus height of the building. So this one will be your answer here. Add this to this, whatever you get, be in meter. That is how to calculate the maximum height above the ground. Use your calculator First of all, simplify this, square this, multiply by 80, whatever you get in meter. The maximum height attained above the ground. So it will be height attained here plus the height of the building. We give you the maximum height above the ground.